The acrid smell of burning metal cuts through the salt air as sparks cascade like falling stars across the oil-stained harbor waters. 3 days after the attack that brought America into the war, USS Nevada sits partially submerged, her hull torn open like a steel flower blooming in reverse. But the sounds echoing across the shipyard aren't those of defeat. They're the rhythmic hammering of rivets, the hiss of acetylene torches, and the determined voices of men who refuse to let steel die. Welders crouch in impossible positions, their masks glowing like fireflies in the ship's darkened compartments. Water sloshes around their boots as they work, sealing wounds that should have sent this battleship to the bottom forever. Above them, cranes swing massive steel plates through the morning air while teams of shipfitters crawl through spaces no human was meant to enter. What the Japanese pilots who flew away 3 days ago couldn't see, what their admirals would never truly understand, was this. Americans didn't just build ships, they brought them back from the dead while the engines were still running. When Admiral Isoroku Yamamoto planned the attack on Pearl Harbor, he understood one fundamental truth about the coming war. Japan would have to win quickly, or not at all. The island nation's industrial capacity could never match America's vast factories and unlimited resources. But Yamamoto and his fellow admirals made a critical miscalculation. They believed that sinking American ships would remove them from the war permanently, just as it would for Japanese vessels. This assumption grew from Japan's own naval experience. When a Japanese warship took severe damage, it typically meant months in drydock, if it survived at all. Japanese shipyards, while skilled, operated under severe material constraints. Steel was precious, welding equipment limited, and trained repair crew as scarce. A torpedo hole in a Japanese destroyer often meant that ship would spend half a year being rebuilt, assuming the resources could be found. The Imperial Navy had built its entire Pacific strategy around this reality. Strike hard, strike fast, and sink enough American vessels to force a negotiated peace before America's industrial machine could respond. Japanese war planners calculated that each major warship they destroyed would remain out of action for 6 months to 2 years. They had studied American industrial capacity and knew that America could eventually outbuild them, but they believed they had time. What they didn't factor into their calculations was the revolution happening in American shipyards. While Japanese admirals focused on tactics and strategy, American naval engineers were transforming the very nature of ship repair. The United States Navy had spent the years before Pearl Harbor not just building ships, but reimagining how damaged vessels could be restored to fighting condition. American shipyards in 1941 bore little resemblance to their counterparts from the previous war. New welding techniques had replaced much of the laborious riveting process. Prefabricated sections could be manufactured in inland factories and shipped to coastal yards for installation. Most importantly, damage control had evolved from an afterthought into a science. The Japanese understanding of American naval capabilities was dangerously outdated. Their intelligence services reported on ship numbers and gun calibers, but they missed the unsexy revolution happening in welding technology and damage control procedures. They saw America's industrial potential as a future threat, not understanding that it was already transforming how wars at sea would be fought. When the first Japanese bombs fell on Pearl Harbor, they were targeting what they believed was a conventional navy operating under conventional constraints. They expected their surprise attack to remove the Pacific Fleet from action for years, giving Japan time to consolidate its conquests and prepare for the inevitable American counteroffensive. Instead, they had just awakened a naval force unlike any the world had ever seen. The transformation of American naval repair capabilities hadn't happened overnight. It began in the late 1930s as tensions rose across both oceans, and Navy planners realized that the next war would be fought on a scale that would dwarf anything in history. Traditional approaches to ship maintenance and battle damage repair would be inadequate for the coming conflict. The breakthrough came from an unlikely source: the construction of the Golden Gate Bridge. The massive welding operations required for that project had advanced American metallurgy and welding techniques far beyond anything available to other navies. Techniques developed for joining steel cables and support structures found new applications in naval architecture. What had been learned building America's infrastructure was quietly being adapted to build and repair America's warships. Navy yards began installing equipment that seemed almost science fiction to foreign observers: portable welding units that could operate underwater, prefabricated hull sections that could be delivered by truck and installed in hours rather than weeks, Most revolutionary of all, damage control teams trained to perform repairs while ships remained in combat zones. The Pearl Harbor attack, devastating as it was, provided the perfect laboratory for these new techniques. USS California, sunk at her moorings with massive torpedo damage, became a test case for underwater welding repairs. Teams of Navy divers worked around the clock, sealing holes while the ship still sat on the harbor bottom. What should have been a total loss was refloated within months. But the real innovation was happening not in the major naval yards, but in hundreds of smaller facilities across the American coast. Liberty ship construction had taught American welders to work faster and more efficiently than ever before. These same skills transferred directly to battle damage repair. A hole that would have required weeks of careful riveting could now be sealed with welded plates in days. The Japanese military attachés who observed American shipyards before the war reported what they saw, but they fundamentally misunderstood what they were witnessing. They noted the impressive scale of American shipbuilding but failed to grasp the revolution in repair capabilities. To Japanese eyes, American shipyards looked inefficient, too much equipment, too many workers, too much apparent waste. They didn't recognize that this apparent excess represented redundancy and capability that would prove decisive once the shooting started. American damage control doctrine had also evolved far beyond its Japanese counterpart. Where Japanese ships relied on watertight compartments and hoped for the best, American vessels were designed from the keel up for survivability. Every major system had backups. Electrical systems could be rerouted through multiple pathways. Fuel lines could be isolated and bypassed. Most importantly, every sailor received extensive damage control training. By December 1941, the United States Navy possessed capabilities that existed nowhere else in the world. Ships could be repaired at sea, in forward bases with minimal facilities, or in rear area yards with unprecedented speed. What the Japanese saw as America's weakness, its emphasis on logistics and support rather than pure fighting power, was actually its greatest strength. They had prepared to fight a traditional naval war, while America had reinvented what naval warfare could be. The men who would prove Japanese assumptions wrong came from every corner of American industry. Joe Kowalski had welded steel beams in Chicago skyscrapers before the Navy taught him to seal torpedo holes below the waterline. Frank Martinez had repaired oil pipelines in Texas before finding himself crawling through the flooded compartments of battle-damaged destroyers. These weren't career sailors, they were craftsmen who brought industrial expertise to naval warfare. Their tools were as revolutionary as their skills. Portable welding units powered by gasoline generators could operate anywhere a ship could anchor. Underwater welding equipment, developed initially for bridge repairs, allowed hull patches to be installed while vessels remained afloat. Most importantly, prefabricated repair sections meant that common damage patterns could be fixed with parts manufactured thousands of miles from the battle zone. The human element was crucial because this new approach to naval repair required a different mindset. Traditional ship repair was methodical, careful, perfect. Wartime damage control was fast, functional, and focused on getting ships back into the fight. These welders learned to work in partially flooded compartments under enemy fire with imperfect materials. They developed an improvisational genius that no naval academy could teach. Japanese naval doctrine, by contrast, emphasized honor, tradition, and adherence to established procedures. Japanese damage control teams were skilled, but they worked within rigid frameworks that couldn't adapt to rapidly changing battle conditions. When a Japanese ship took damage, the response followed predetermined protocols designed for peacetime repair facilities. There was no tradition of field expedients or battlefield improvisation. The technological gap was even more profound than the human one. Japanese welding equipment remained largely unchanged from pre-war designs. Their portable repair capabilities were limited, and underwater welding was virtually unknown. Most critically, Japanese ships weren't designed for the kind of rapid field repairs that American vessels could undergo. Their damage control systems were sophisticated but inflexible. This difference in approach reflected deeper cultural and economic realities. Japan's resource constraints had created a military culture that valued perfection over speed, quality over quantity. Every piece of equipment was precious and had to be used carefully. America's abundance allowed for a more experimental approach. If a repair technique failed, there were always more materials and more opportunities to try again. The tactical implications of these differences wouldn't become clear until ships began taking battle damage in earnest. Japanese admirals planned their operations assuming that damaged American vessels would withdraw from combat for extended repair periods, just as Japanese ships would. They expected to fight a war of attrition where each exchange of damage would gradually favor the side with better initial position and tactics. Instead, they found themselves facing an enemy that seemed to regenerate like a living thing. American ships that should have been sunk returned to battle weeks ahead of schedule. Damage that should have been crippling was repaired at sea. Most frustrating of all, American vessels often seemed to become more dangerous after taking damage, as crews learned to compensate for lost systems and repair teams strengthened weak points. Admiral William Bull Halsey understood what his Japanese counterparts did not, that naval warfare had become as much about logistics as firepower. While enemy commanders focused on gun calibers and torpedo ranges, Halsey built his strategy around America's unprecedented ability to keep damaged ships in the fight. His task forces carried repair ships, floating dry docks, and damage control specialists that could restore battle damage faster than the Japanese could inflict it. The American approach required a fundamental reimagining of naval command structure. Traditional navies separated combat operations, rations from maintenance and repair. American task forces integrated these functions with repair specialists serving alongside combat crews. Damage control became the offensive weapon, allowing American commanders to take calculated risks that would have been suicidal for any other navy. From the Japanese perspective, American naval tactics often seemed recklessly aggressive. Ships advanced into situations where they would inevitably take damage, apparently unconcerned about the consequences. What Japanese observers couldn't see was the invisible infrastructure that made such tactics possible. American ships could afford to take risks because they could be repaired quickly and efficiently. Japanese intelligence services struggled to understand what they were seeing. Reports from the front lines described American vessels that seemed almost indestructible. Ships that had been reportedly sunk appeared in battle again weeks later. Damage that should have required months of repair was fixed in days. Some Japanese commanders began to suspect that America possessed secret technologies or that their own damage assessments were systematically wrong. The reality was simpler but more profound. America had industrialized naval warfare in a way that no previous military had achieved. The same assembly line techniques that produced thousands of Liberty ships were applied to battle damage repair. Standardized procedures, interchangeable parts, and specialized teams created a repair capability that seemed almost magical to enemies accustomed to traditional methods. The psychological impact on both sides was enormous. American crews developed an almost supernatural confidence in their ship's survivability. They knew that even catastrophic damage could be repaired, that their vessel could be brought back from the edge of destruction. This confidence translated into tactical aggressiveness and strategic persistence that repeatedly surprised Japanese forces. For Japanese sailors, the American repair capability became a source of growing demoralization. Ships they had damaged or believed destroyed kept reappearing in battle. The war of attrition they had expected to win gradually turned against them as American vessels proved far more durable than predicted. Victory seemed to slip away not through decisive defeat, but through the grinding reality that their enemies' ships simply wouldn't stay sunk. The moral dimension of this technological advantage was significant. American damage control represented the application of civilian industrial skills to military problems. The welders and fitters who kept American ships fighting were citizen soldiers using the same techniques they had employed in peacetime construction. This gave the American war effort a democratic character that contrasted sharply with the hierarchical precision of Japanese naval operations. The moment when Japanese assumptions collided with American reality came in the waters off the Solomon Islands in the autumn of 1942. USS South Dakota had taken a direct hit from a 14-inch shell that should have put her out of action for months. The projectile had torn through her forward superstructure, destroyed vital electrical systems, and started fires that threatened her magazines. By every conventional measure, she should have withdrawn from combat immediately. Instead, damage control teams swarmed through the burning compartments while the battle still raged around them. Welders sealed ruptured steam lines while machinists rerouted electrical cables through undamaged sections of the ship. Most remarkably, they did this work while South Dakota continued to fire her main batteries at Japanese positions. The ship was being repaired and fighting simultaneously. Japanese observers couldn't believe what they were seeing. Admiral Hiroaki Abe, commanding the enemy force, had counted South Dakota as effectively destroyed when his shells struck home. His tactical calculations assumed she would withdraw, leaving a gap in the American line that his ships could exploit. Instead, the American battleship not only remained in position, but seemed to increase her rate of fire as the battle continued. The scene playing out in South Dakota's damaged sections would have been impossible on any Japanese vessel. American damage control doctrine emphasized cross-training and improvisation. Sailors who normally operated radar systems found themselves wielding welding torches. Cooks and clerks formed human chains to pass ammunition through compartments where normal supply routes had been destroyed. The rigid specialization that characterized Japanese naval operations would have made such flexibility impossible. What made this possible was technology that Japanese naval architects had never imagined. Portable welding units allowed repairs to begin immediately without returning to port. Modular electrical systems meant that damaged circuits could be bypassed in minutes rather than hours. Most importantly, South Dakota had been designed from the beginning with battle damage in mind. Her systems included redundancies and repair provisions that Japanese ships lacked. The welders working in South Dakota's forward sections were performing what amounted to surgery on a living patient. They had to seal ruptured hull plates while seawater poured through the gaps, weld new structural supports while the ship rolled in heavy seas, and restore electrical power while enemy shells continued to fall around them. The work required not just technical skill but physical courage of an extraordinary kind. Japanese damage control procedures, by contrast, followed careful protocols designed for dry dock conditions. When Japanese ships took serious damage, the emphasis was on damage assessment, casualty evacuation, and preparation for towing to repair facilities. The idea of conducting major structural repairs while under enemy fire was simply not part of their operational doctrine. The battle that night proved to be a turning point not just tactically but psychologically. Japanese commanders had expected to face an enemy that would withdraw damaged vessels from combat, allowing superior Japanese tactics and gunnery to prevail over time. Instead, they found themselves fighting ships that seemed to become stronger as the battle progressed, repairing damage faster than it could be inflicted. As dawn broke over the Solomon Islands, the full extent of American repair capabilities became clear to Japanese observers. USS South Dakota, which should have been a smoking wreck limping toward the nearest Rhinely port, was steaming at full speed with her damage control team still working. Smoke still rose from her forward sections, but her guns remained in action and her engines maintained full power. More disturbing to Japanese commanders was what happened in the hours that followed. American repair ships moved alongside South Dakota while she remained in the combat zone. Instead of withdrawing for extensive repairs, she received what amounted to battlefield surgery. Welders worked from floating platforms to seal the largest hull breaches. New electrical cables were run through external conduits where internal systems had been destroyed. Damaged gun mounts were restored to operation using parts fabricated on the spot. Admiral Abe's after-action reports to Tokyo struggled to explain what his forces had witnessed. Japanese naval doctrine had no framework for understanding an enemy that could conduct major ship repairs in forward combat areas. The American ability to restore battle-damaged vessels without returning to major naval yards represented a fundamental shift in the nature of naval warfare. The Japanese response revealed the limitations of their own system. Damaged Japanese vessels had to withdraw hundreds of miles to reach repair facilities adequate for major structural work. Even minor damage often required weeks of careful restoration in well-equipped yards. The idea of welding new hull plates while enemy aircraft could still attack was inconceivable within Japanese operational doctrine. What the Japanese couldn't see was the vast infrastructure that made American field repairs possible. Floating repair shops carried sophisticated welding equipment and machine tools that could fabricate replacement parts for almost any shipboard system. Damage control specialists had been trained not just to contain damage but to reverse it, restoring full capability to systems that conventional wisdom would have written off as total losses. The psychological impact on Japanese naval personnel was profound. They had been trained to expect that battle damage would follow predictable patterns, with severely damaged vessels withdrawing from combat for extended repair periods. Instead, they faced an enemy that seemed to regenerate its strength through some form of technological magic they couldn't understand or counter. American crews, meanwhile, developed an almost mystical confidence in their ship's ability to survive and continue fighting. They had seen vessels brought back from what should have been fatal damage. They knew that even if their ship took devastating hits, the welders and repair specialists could probably keep her fighting. This confidence translated into tactical aggressiveness that repeatedly caught Japanese forces off guard. The Solomon Islands campaign became a laboratory for American damage control techniques. Each battle provided new lessons in field repair capabilities. Welders learned to work in increasingly difficult conditions. Electrical specialists developed new methods for rerouting power through damaged systems. Most importantly, the integration of repair capabilities into combat operations became so smooth that American task forces could maintain their offensive pressure even while conducting major restoration work on damaged vessels. By the end of 1942, Japanese naval intelligence was reporting phenomena that seemed to defy conventional understanding of naval warfare. American ships that had been confirmed as sunk were reappearing in battle. Vessels that had taken what should have been crippling damage were back in action within days rather than months. The war of attrition that Japan had expected to win was turning into a contest of repair and regeneration that they were clearly losing. The numbers told a story that Japanese admirals found almost impossible to believe. By mid-1943, American ships were returning to combat an average of 6 times faster than Japanese vessels suffering comparable damage. A torpedo hit that would keep a Japanese destroyer in dry dock for 4 months resulted in only 3 weeks of reduced capability for its American equivalent. The gap in repair speed was becoming a decisive factor in the Pacific War. USS Franklin provided the most dramatic example of American repair capabilities. After taking devastating damage from Japanese kamikaze attacks in March 1945, she should have been written off as a total loss. Her flight deck was destroyed, her hull was riddled with holes, and fires had gutted large sections of her interior. By Japanese standards, Franklin was beyond salvage. Instead, damage control teams began repairs while she was still under tow, working around the clock to restore basic functionality. The carrier that limped into Pearl Harbor 3 weeks later bore little resemblance to the vessel that had been attacked. Welders had sealed hundreds of holes in her hull. New electrical systems had been jury-rigged through undamaged sections. Most remarkably, her flight deck had been restored to partial operation using prefabricated sections flown in from West Coast yards. Franklin was conducting flight operations again within 2 months of an attack that should have ended her war. Japanese damage control capabilities, meanwhile, remained locked in pre-war patterns. When heavy cruiser Chokai took torpedo damage in October 1944, she required 4 months of repair work that could have been completed in American yards within 3 weeks. The delay wasn't due to lack of skill among Japanese shipyard workers, but to systemic limitations in equipment, materials, and doctrine that made rapid repairs impossible. The disparity extended beyond major combat vessels to the smaller ships that kept fleets operational. American destroyer escorts and patrol craft carried portable welding equipment and trained repair specialists. They could conduct significant repairs while anchored in forward combat zones, often restoring full capability without returning to rear area bases. Japanese equivalent vessels had to withdraw to major naval yards for repairs that American crews could handle at sea. More telling was the difference in ship design philosophy. American vessels built during the war incorporated lessons learned from early battle damage. New construction included improved damage control systems, redundant electrical pathways, and structural features that facilitated rapid repair. Japanese ships, constrained by material shortages and industrial limitations, continued to follow pre-war designs that emphasize combat effectiveness over survivability. The industrial infrastructure supporting these repair capabilities represented one of America's greatest strategic advantages. Welding equipment manufacturers had expanded production to meet military demand. Training programs turned out thousands of skilled repair specialists. Most importantly, the techniques developed for military use were already being adapted for post-war civilian applications, ensuring that these capabilities would outlast the immediate military need. The strategic consequences of America's repair advantage became clear in the final year of the Pacific War. Japanese naval forces found themselves fighting an enemy that seemed to possess an inexhaustible fleet. Ships they had damaged or believed destroyed kept returning to battle, often in improved condition. The attrition strategy that had formed the basis of Japanese naval planning had been completely undermined by American technological capabilities. Admiral Suemu Toyoda, who commanded the Japanese combined fleet in its final battles, later admitted that his forces had been unprepared for an enemy that could regenerate its strength so rapidly. Japanese war planning had assumed that battle damage would accumulate over time, gradually reducing American capabilities. Instead, they found themselves facing task forces that maintained constant strength despite taking regular losses. The kamikaze campaign of 1945 represented a desperate attempt to overcome American repair capabilities through overwhelming damage. Japanese planners calculated that suicide attacks could inflict damage faster than American repair teams could fix it. Even this extreme measure failed to account for the speed and effectiveness of American damage control. Ships that took multiple kamikaze hits were often back in action within weeks, their crews having gained valuable experience in rapid repair techniques. The human cost of this technological advantage extended beyond American forces. Japanese sailors, knowing that their own ships lacked equivalent repair capabilities, became increasingly cautious about accepting battle damage. American crews, confident in their vessels' survivability, maintained aggressive tactics that consistently achieved tactical surprise. This psychological dimension of the repair advantage may have been as important as its practical benefits. Post-war analysis revealed the full extent of Japan's miscalculation. American shipyards had repaired and returned to service vessels representing over 2 million tons of shipping that Japanese forces believed they had permanently removed from combat. The Phantom fleet of supposedly destroyed American warships had been one of Japan's most dangerous enemies, representing combat capability that should not have existed according to conventional understanding of naval warfare. The techniques developed during the war revolutionized civilian shipbuilding and repair in the post-war era. Welding methods perfected under combat conditions found application in commercial shipping. Damage control procedures developed for military vessels improved safety standards throughout the maritime industry. Most importantly, the integration of repair capabilities into operational planning became standard practice for naval forces worldwide. Japanese naval officers who survived the war often spoke of their amazement at American repair capabilities. They had been trained to expect that naval combat would follow certain predictable patterns, with damaged vessels withdrawing from action for extended periods. The American ability to maintain operational tempo despite taking significant battle damage represented a fundamental change in the nature of naval warfare that they had been unprepared to counter. The legacy of American wartime repair capabilities extended far beyond the immediate military context. The industrial techniques, training methods, and operational doctrines developed during the war established American leadership in naval technology that would persist for decades. What had begun as a desperate response to Pearl Harbor had evolved into a strategic advantage that helped define the post-war world order. In the end, the story of American naval repair capabilities during World War II represents more than just technological superiority. It embodies a fundamentally different approach to warfare, one that emphasized resilience over perfection, adaptability over rigid doctrine, and industrial might over traditional military virtues. The welders who sealed torpedo holes while ships still sailed were not just craftsmen, they were revolutionaries who transformed the very nature of naval combat. Japanese admirals never truly understood what they were fighting. They prepared for a war against a conventional navy operating under conventional constraints, only to find themselves facing an enemy that had industrialized the process of resurrection. American ships didn't just fight, they evolved, learning from damage and emerging stronger than before. This represented a new form of warfare that transcended traditional concepts of victory and defeat. The broader lesson extends beyond naval history to the nature of technological competition itself. Superior weapons and tactics can provide temporary advantages, but superior systems for recovery and adaptation create lasting strategic dominance. America's greatest achievement in the Pacific War wasn't building the world's largest navy, it was creating the world's first truly regenerative military force. The welders and damage control specialists who kept American ships fighting deserve recognition not just as skilled craftsmen, but as the architects of a new kind of warfare. Their torches and hammers were as decisive as any weapon carried into battle. In transforming the temporary into the permanent, damage into opportunity, they helped write the final chapter of the last great naval war in human history.